Imagine the roar of engines in Birmingham, UK, 2022, where cutting-edge AI collides with aerodynamics. Using computational fluid dynamics, CFD, engineers feed trillions of digital airflow data points into AI-powered loops. Companies like Siemens SimCenter are now guiding every stage, from mesh generation to real-time flow predictions, using GPUs and cloud supercomputers. In Munich, Germany, Altair, acquired by Siemens in March 2025 for a staggering $10.6 billion, showcased AI-driven topology optimization at the Paris Air Show 2025. Their HyperWorks suite sculpted lighter, stronger winglets, structures so organic, they couldn't be crafted by hand. In Milton Keynes, England, Red Bull Advanced Technologies partners with Ansys to supercharge Oracle Red Bull Racing. Since 2008, they've used Ansys Fluent and Ansys SimAI to iterate aerodynamic concepts in minutes instead of weeks. In 2024, Ansys revealed SimAI can evaluate design variants 100 times faster. Matt Kaju, RBR's CIO, states, "Simulation gives us the edge, we iterate aero designs much faster." By 2020 to 2023, computer-aided design, CAD, platforms from Autodesk, integrated with AI simulators, became essential. Precise wing profiles, cooling ducts, flow straighteners, all digitally born and optimized. When the digital blueprint is validated, industrial 3D printing constructs these impossibly intricate parts, shapes no machinist could fabricate. Today, this synergy is standard. Companies like Siemens, Altair, Red Bull, Autodesk, and Ansys make AI-driven aerodynamic design not a novelty, but mandatory. Every curve, winglet, and duct is born in code, refined by AI, and brought to life via additive manufacturing. The future of F1 is no longer imagined, it's already being printed, simulated, and raced. And if we didn't know, now we all do.